that shows observational study design, where it can be split, where it can be split into two. I mean, the descriptive and analytical aspect of it. So the presenter dwell well on descriptive aspect of observational study, under which she explained case study, case series, cross-sectional. But for tonight, we look at the analytical, because the details that we need to know as far as this is concerned, they have talking about that in the immediate past class. So today we are looking at the design. I believe you can all hear me, please. Can you all hear me?
Yes, I can hear you, sir, from my end. Yeah. Yes, I can hear you, sir, from my end.
The topic for tonight is analytical study design. This one is is not looking at, it's not observing alone. It's not observing alone. This one is designed to examine etiology and even causal associations. But in the previous one we talk about, we can determine the etiology, we can determine the causal association. And the other one we talked about, I mean, this is a cross-sectional. That cross-sectional is just trying to give us a kind of a idea of hypothesis. We can even, that one is used to develop hypothesis. But in this one, this is where we can even test, we can test hypothesis. So that it shows that this analytical study design is a little bit the other one that we talked about in our last class. Analytical study design, it has analytical study design, it has divisions, it has the classes. You have case control, repeated cross-sectional, and correlation. So let's talk about the cohort study as one of the type of analytical study design. Cohort study, follow-up study, or longitudinal study, as well as concurrent study. This is an example of observational study. The investigator, I mean the researcher, takes measurement but does not intervene. It does not, the investigator not manipulate. Whenever the investigator is manipulating or intervening, it shows that that particular research is no longer observational. It's now experimental in nature. So for the cohort study, the aim of the study is to find out if there is any association between the development of a disease and exposure to a suspected etiological agent or factor. They produce the best information about the causation of disease. They also call, just like I've mentioned earlier, they also call follow-up studies. Generally, there are two types of cohort study. We have retrospective cohort study as well as prospective cohort study. For the retrospective cohort, this is where the population at risk can be defined at some time in the past and traced forward in time. It's more or less like historical study. For the cohort study, we have mentioned it that cohort study is, they also call it concurrent. It means that you start with a set of a participant, I mean study participant. You monitor them over a period of time. But talking about retrospective, instead of moving forward, moving from like we are in now, we are today is February 2nd, 2025. Instead of now starting the research from today, then moving forward to like maybe 2026. As far as retrospective cohort study is concerned, it will not go like that. We will start in the and take it. We move it up to the moment. I mean, for instance, let's say we are studying a particular report, and that report, we want to look at the one that started of that nature. It shows that we are doing retrospective cohort study. It's concurrent because we monitor it. We are trying to observe the changes and everything. We are trying to. We have interest in monitoring there, right from maybe January 2024 down to the present time. So that's why it is retrospective, historical in nature. It's like a backward study. We're talking about prospective cohort study. where the population is identified and assembled by the investigator and then followed forward in time. In this prospective cohort study, the researcher now then continue trying to see it over a certain period of time, assuming that you want to study the effect of cigarettes. The people that are smoking, you want to look at whether they can come down with maybe cancer or maybe diabetes or heart attack, something like that. I want to monitor it from today till the next 6 months. It's no longer restrictive because we are not moving backward. We are moving forward, right from where we are today. Then forward, we are moving it forward. We are looking at certain period of time in future. So that was prospective cohort study. Prospective cohort study. I believe you have seen little difference between retrospective cohort study and prospective cohort study. Let's look at the chart. Can you all see this chart, please? Hello? Can we see the chart? Hello?
Yes, sir.
This chart, I'm trying to use this one to illustrate the difference between prospective cohort study and retrospective cohort study design. For the first line, for the first arrow, we have prospective. The selection of exposed and unexposed, we determine it right now. I mean, the investigator determine who are the exposed, who are the unexposed participants. From now, I mean, as at now, 2025, February 2nd, then follow up to 2029. The study is prospective. Then, if you are trying to start from the past, saying that from 2009, they will now start following the records up to this moment, 2025. That's second arrow that I'm showing now. That one is retrospective cohort study. Then we have under cohort study again, we have, just like I mentioned, they have numerous names. They call it concurrent study, they call it longitudinal, they call it even cohort, just like I've mentioned before. But we have types, just like I've mentioned in the previous the diagram I just shown us. We have retrospective, we also have prospective. Prospective, same thing as concurrent study. Then the retrospective is historical in nature. We call it historical cohort or non-concurrent study. We can also have both of them mixed in such a way that we are trying to see maybe the effect of smoking and the development of cancer, and we try to look at, we get some participants, assuming that we are looking at 20 participants. We have 10 for those people that have started smoking voluntarily without anybody telling them that they should engage on smoking. We have 10 of them. Then we also have another 10 participants, they are not smoking. Maybe we have them in 2024, January 2024. I want to look at it, we want to see whether those people that are taking cigarettes, they are smoking, will come down with cancer in 2026. So if you are getting it, you are following me very well. The researcher want to start the study from backward from 2024 January down to 2026 December, and we are now in 2025. That particular study, that one is retrospective prospective study. Retrospective prospective study. That was mixed design. Then for the first one, if you are looking at this chart, we have concurrent study, we have non-concurrent study, we have mixed. For the first one, which is concurrent, we are starting now moving forward. That's why it is follow-up. But for the non-concurrent study, it's historical. We start in the past, we move it, we study up to the moment, and we are not moving forward again. We stop there. Then for the last one, which is mixed design, we try to look at what we are trying to study, right from the time in the past down to the present time, and also move it forward to future time. So I think we understand the difference between these three types of cohort study. Then the methods. If a researcher want to conduct a cohort study, this is the method that is going to use. The researcher will start with maybe people without the disease of his interest. Then divide them into two groups based on exposure into this factor being investigated. They're trying to tell us that you assume that you want to carry out a study on cancer or maybe on HIV and unprotected sex. Whether people that are having unprotected sex will come down with HIV or not. Then you get participants, instead of participants, you divide them into two. The first part, they are having unprotected sex. Then the other set, which is group 2, they are not having it. And we are trying to see whether after a period of time, those people that are not protecting themselves will come down with maybe HIV or not. Or maybe those people that are protecting themselves will also develop the same disease of interest, which is HIV or not. That's what this chart is trying to explain to us. The population that has POP, be free of disease. People that are free from disease, we get them. Then we divide them into two. First set, the exposed protected sex. In this, as far as this scenario is concerned, the illustration I'm trying to use is concerned. Then the second group, they are not exposed, meaning that they are protecting themselves. They are not having unprotected sex. Then the exposed that we are seeing here, there is we all believe that if they exposed to these, if they are having unprotected sex, some of them will come down with disease. And to our surprise, some of them might not even come down with disease. They may be having unprotected sex and still yet they will not develop HIV. But there are some, that's group 2. They are not exposed. They are not having unprotected sex. But still yet, some of them will still develop disease. Some of them will still come down with HIV, while some will not even have the disease. So these two groups, the first one, they are exposed. The second one, they are not exposed. Then we try to look at whether those that are exposed will come down with disease, and some of the people that will not even come down with disease. And for the not exposed, we still look at it whether after certain period of time that we have in mind that we want to carry out the study for, whether they will come down with disease of interest or not. The two groups should be similar. That's another key that we need to hold on to whenever we are carrying out cohort study. The group we are going to use, because I said in the previous slide now, just immediate previous slide, that we are going to have two groups. The first one, they are exposed to disease of interest. The second group, they are not exposed to the disease we are to look into, trying to carry out research on. But one of the most important thing is that both participants, in both groups, the participant in both groups must be similar. Only difference is exposure to a suspected etiologic agent. If for the exposed, if they are female, the non-exposed also will be female. If it's even better, more preferable, we look at the race from where we get them, just to make sure the two groups they match each other, just to avoid some level of bias. This is done by matching. The group is done by matching, as we can recall. It can be individual or group matching. The matching we are talking about can be individual or it still be based on group. The next step is to follow up the exposed and non-exposed group for a period of time. Meaning that we observe the disease of interest that we have in mind in checking. We are trying to see whether they will come down with it or not. During this period, you are determining the disease of interest in the two groups. The group that are exposed and the group that are not exposed. In the mind of researcher, investigator, he still have it in mind that he's trying to check whether in the exposed, whether they will develop the disease of interest or not. At the same time, in the group that are not exposed to, he's still trying to see whether they will still come down with disease or not. It's not like the researcher is looking at one group, like saying that, okay, just because I know that this group are exposed already, definitely they will come down with disease. And let me just neglect those groups that are not exposed. No, as far as cohort study is concerned, the researcher look into two groups, monitor them, observe what is happening in each group, and take the recording of it. Then this analysis, there are some analysis that we can do while conducting, while conducting cohort study, just like the presenter of the last class mentioned. For the cross-sectional study, we cannot be calculating something like a incidence risk, a relative risk, attributable risk. In that one, the only thing we are trying to look at is prevalence. We can't talk about incidence. But for the analytical, we are talking about, and I mean, in particular, cohort study, the researcher can calculate, the researcher can make some calculation. Part of the calculation the researcher can do as far as this study design is concerned is relative risk, in which the relative risk can be calculated by saying that by looking at the incidence of disease in exposed. Let me try to take us back a little bit. I said for the core study, when the researcher is trying to start the study, the researcher gets participants and he divides the participants into two groups. The first group, like group 1, they are exposed to disease of interest of that researcher, saying that maybe the researcher is trying to look at the effect of unprotected sex on development of HIV. So for the first group, that one is exposed, meaning that the participants in that group, they are having unprotected sex. They like to see over a period of time will come with HIV, which is disease of interest to that particular researcher. And the second group, that one is not exposed, meaning that they are not having unprotected sex. And in his mind, he's trying to see whether those that are not exposed, whether they will still come down with disease or not. And likewise, we have two outcomes. We have some that will develop disease, and we have some that will not develop in exposed. The rate of people that will come in the group that are exposed already. In that one, if you look at the table I have here, for the exposure and no exposure, disease and no disease. In the exposure, we have A, other disease, and in the exposure also for the no disease aspect, that's B, which shows that for people that are exposed, some of them will still come down with disease. That's A. A is representing those groups. Some will still not come down with disease, even though they are having unprotected sex. Therefore, no exposure. They are having, they don't have unprotected sex. But some of them will still come down with disease. Maybe this or other source sexual life. Some of this, the total of the population under exposure A, we have B. Then the incidence of those that have come down with disease is A as incidence of disease in exposed. The incidence of disease in exposed, incidence of disease in non-exposed. The set of people in this group of non-exposed that come down with disease, because we all know that as far as this table is concerned, it's not all of them that come down with disease. It's those that come down with disease, even though they are not exposed. And letter D represent those that do not come down with disease. Then they are not even exposed to this particular unprotected sex, just like I've been using this kind of example. So in that case, incidence of disease in non-exposed now be C over C plus D. C over C plus D. Then to now calculate the relative risk, it will be incidence in exposed over incidence in non-exposed. exposed. We all know that if you go through this calculation, you are going to get a particular value at the end of the day as our outcome. If our final answer for the calculation is greater than 1, it shows that it means that the risk of acquiring the disease is higher in those who are exposed. The disease of coming down with the risk of developing HIV in this context is higher among the participants that are exposed, among the participants that are having unprotected sex. Then when the relative risk is equal to 1, that there is no association at all between the exposure and the disease outcome, which means if there is not, the outcome still remain the same. Risk is the same in both the exposed and non-exposed. But if the relative risk, how is less than 1, it means that exposure reduces the risk of acquiring the disease. For instance, in the previous slide I just mentioned here, they have been using unprotected sex and development of the people that are exposed disease, and some of them also did not come down with disease. But for the not exposed, some come down, some did not come down. Then, if you now look at that one, if the incidence in if now calculate the relative risk, and we later discover that our final answer is less than 1, it shows that those people that are exposed to unprotected, they even stand better chance over those that are not even over the other group, over that what are less than 1 means. If they are not protecting their sex, then it reduces the chance of developing what? HIV disease. So I believe we understand the interpretation of the outcome we are going to have as far as the relative risk is concerned. Then the next aspect of analysis that we can do as far as the quality is concerned, to calculate attribute. Yes, it can be calculated for us study. Attributable risk is the amount of risk that can be ascribed to the exposure for the HIV and unprotected sex. The amount of risk we can ascribe, we can attach to the exposure to not having sex contact. Attributable risk is the amount of risk that can be ascribed to the exposure. It measures the excess risk in those who are exposed. It measures the excess risk in those who are exposed. Difference in incidence of those with risk factor and those without. So we are trying to calculate the attributable risk, unlike the previous one that we just did, which is a relative risk. That one we take the fraction. But as for attributable risk, we look at the difference between incident rate in exposed, incident rate in unexposed. For us to get attributable risk, for us to calculate attributable risk, we need to take the difference. We need to subtract the incident rate of unexposed from incident rate of exposed. We should not relative risk is concerned. Relative risk, we take the fraction, so difference between them. Attributable risk measures the impact of the removal of a certain factor may have on the incidence of, to look at the effect that the removal of a certain factor may have on the development of a particular disease, on the chance of having that disease, or the occurrence of that disease. Relative risk measures the strength of association. Now, trying to see the difference now. The relative risk is trying to measure the strength of association, how strong they are associated to each other. But for the attributable risk, that one is trying to measure the impact, the effect of the removal of a certain factor may have on the incident rate, We are trying to, for the attributable risk, they are trying to see whether if they withdraw the exposure, it's going to have a particular effect on the development of a particular disease of interest or not. That's what we are trying to measure as far as attributable risk is concerned. But for the relative risk, we are trying to see the level of association between the exposure itself and the outcome. So relative risk measure the strength of action. The higher the relative risk, the greater the association of the factor to the disease. Therefore, a high relative risk is suggestive of etiology, but not always. The advantages of a cohort study, you can determine incidence in exposed and unexposed. You can determine incidence in exposed and unexposed because the researcher is trying to observe the both two groups he has. He has one group that is exposed. He has another group that is not exposed. And he's trying to see the level of incidence rate in both at the same time. The second advantage is that you can measure the relative risk, in which in cross-sectional study, we cannot do that. We can only check the prevalence. We can determine prevalence. We cannot check the relative risk. Another advantage of it is that no recall bias. Why? Because you have your participants in both groups. You are till a period of time of you want to look to study stop people that you have grouped them to two groups, and you are trying to see the effect of particular exposure on their on the outcome of interest. Maybe for like 6 months, you start now, then you move forward to next 6 months. Everything you need to ask them, you are seeing it every day, and you are asking them, or you are observing it as at when due. It's not like we are trying to skip a day or try to skip a certain period of time. They will come and ask them later. We are getting our response very fresh. The time that we need the response from the participant, that's the time we are asking it. Or the time we need to observe certain things as far as the our study is concerned, that time that we are observing. So there is no need for the participant to last at exact time that we need it. So that's why there's no need. We don't have something like a record bias. We don't have that. Then another advantage is that you can test for multiple outcomes from exposure. Then you standardize your methodology and reduce probability of bias because we are monitoring it. The researcher is monitoring it from day one to the last day. He's seeing everything that is happening there. There's nothing like, okay, unlike the next type of analytical study against control to be asking cohort study, as we all know. And imagine we are trying to carry out a particular study that takes us like 6 months or 2 years. It is time consuming. It takes time, often require a long time for follow-up. Therefore, since it is even taking time, it might be expensive. It's expensive. It is very, very costly. You need a large sample size. Why do we need that? Because it is difficult to keep the participant the exact number that we have from the day one to the last day. Yes, they have freedom to partake or not to partake. They can drop out at any time. So one of the disadvantages of it is that difficulty with follow-up and people may drop out. That's attrition. So it is time consuming, it's expensive. You need a large number, you need a large sample size. You can't just start with a very small sample size because before you finish all of them are from and we cannot say they should not withdraw because they have liberty to do that. You can't force them to to do it. And that's all for cohort study. Are we together, please? Can you all hear me? Hello? Yeah. The next type of analytical study that we are looking to is case control study. It is a type of analytical observational study. Agents that is control are identified too. And the two groups are compared with respect to primary. The case control, we can it's not cohort. We the research the researchers that have developed a disease of interest is not looking at whether the study as part of the selection for case control study. And between case and the control that particular disease. So in this one, we get the participant, we get the case which has already developed, the person that has developed the disease of interest already. Also, let's go back to the previous example I used, unprotected sex and development of if somebody wants, even we have some criteria for using each and every study design that we have been talking about right from when we started. I mean, not even from today's session, from the previous sessions. There must be a reason why we are choosing a particular study design. Our research questions, objective, will determine the type of study design that will be suitable for that particular study that we want to do. So if we want to now do a study, for us to even say we will gather participants, we group them, we monitor them or not. If that disease is rare, we may even spend 2 years or more than that without having a rare disease. When we know that if you are to say monitoring our participants, that they will develop it or not, they may not end up developing it. So we look for the participant, or we look for the people or the person that have developed that disease already. Then we look for another group of people or individual that do not have that particular disease. Those that have, they are cases. Those that do not have, they are control. And we do it in the past, not like in the present. Example, a case is a person or an individual that need the having unprotected. The outcome here is HIV. The exposure is the unprotected sex. So, and you are trying to see whether those people that have been having unprotected sex have come down with HIV or not. So, but the HIV is not, we can't say it's very rare. It's not that very rare. It's not that very rare. So for this one, example of something that we can just lay our hand upon now is that lung cancer, the left lymphoma, because my lymphoma, and I've even got to know normal is rare. It's one of rare disease in oral health. So for somebody to say people that have developed normal already are now trying to get the control to now be asking them questions about their exposure. Then the outcome of interest. It is usually advisable to use control from the same population exactly that place or around the place where we are going to get another person that is free from this particular disease, which is normal. I mean normal. So in this context now, we are trying to get the case from a particular area, and that the same area we are still going to get our control to reduce level of bias. So should be comparable to case. I mean the control should be comparable to cases. That's why we need to get them from almost the same place. Even we look at the gender. Should have the potential to become where we are going. The individual or set of people we are going to use as our control must also have the chance of that particular disease, even though they don't have yet. Then they stand the chance of even having it. You cannot just say you go to area where you don't have that particular disease of interest that we are looking to pick control. I will just, for instance, maybe we have certain disease that is common in Plateau, for instance, and we know that particular disease is not common in Port Harcourt. So we now try to pick the case here in Plateau and go to Port Harcourt to bring control. That is not comparable. The environment, the exposure is different. They are not even in the same environment. They don't have the same exposure. That not having the same exposure may even affect the result that we are going to get at the end of the research. So should cases, I mean the control should have the potential to become cases, must be susceptible to the disease of interest. Matching that we are treating now, we have mentioned that to have like two groups. The one that those that have come down with disease of interest and the second group, that is their cases. Those that do not have the disease of interest, they are control. The match now should compare to see whether they have high level of similarity, whether they share almost the same characteristics, except the disease of interest. It is the process, the matching is the process of selecting controls so that they are similar to cases on certain specific characteristics, such as age, race, gender. They must belong to the same race, they must be the same gender, their age must be very close, even if they are not the same exactly, but there must be the very close to each other. It is a technique to reduce potential confounders. The essence of matching, the essence of making sure that they come from the same age, they are of the same age, they are from the same race, they have the same gender, just to make sure we reduce some potential confounders, because there are some certain variables that may be affecting based on individual level. So, but for the group, we look at the proportion of that particular group. Maybe in group one for the group matching, in group 1, 15 and 5 of them are about to group 2, the second group also, and see that the same numbers of female we have there, that's the same numbers of female we are having in the other group. Likewise for the male. But for the individual, it's based on individual. We look for the case, then we look for the control to match it. Then we get another case, we look for another control that match that another case that we have gotten. That's what they mean by individual matching and group matching. Because subjects are identified after the disease has developed. That's another reason why the case control or another difference between case and the control, the disease has been developed before commencing the research itself. But for cohorts, it is later that when we have started the research, then the research is ongoing. Maybe we get to the certain period of time that we have set for ourselves, then that particular disease develop, or even before we even reach that particular period of time that we have set in mind that we will do the research for. So for the case control, the disease of interest must have been developed already. And inquiry then, yes, and inquiry then investigates prior exposure. The disease has been developed. The researcher has gotten the case, look for, then try to add case. Maybe, for instance, for someone that have come down with pneuma as a disease, which can you tell us the nature of water that you are taking in your environment? What of the, are you taking maybe like balanced diet? What happened when you are so years of age and things like that in the past, not now, in the past. Then we also get control from that, the same area where we get our case. I also have the same questions. We have the same question. From there, we now come up with our findings. So in short, this one is talking about, this one is historical in nature because we are trying to ask what happened in the past. So the case control study is sometimes referred to as retrospective or backward study design. So case control studies can use prevalence cases that is existing at the time the study begins, or incident cases that is newly diagnosed during the period of the study. Span for cases and also for control. Okay, we look at the population of interest. Maybe we are trying to conduct research, or we are trying to do case control study on NOMA in Plateau State. Then the population is plateau populace. Then we select the study participant from the entire population, those that are willing to do it. From there, we get our case. Meaning that must have known that that particular disease of interest, we can find it there before we even start the study. So we get our cases from that, the same population, that's reference population. Then from that reference population again, we get our control. Then we now try to compare them. We ask questions about the prior exposure, then that will make us to even get the outcome of interest that we are looking for. Because case control studies select participants on the basis of whether or not they have the disease. The case control design does not provide an estimate of incidence or prevalence of the disease. It has happened occur. The disease have developed occur. It has developed already before you even started the study. So saying that you want to now estimate the incidence, whether the disease will occur, or prevalence, the occurrence of it, we don't do this in the case control. We can do that in some other study design that we have explained. Measure of association. In case control, we cannot do relative risk. We cannot do attributable risk. So it means that we can't even find incidence rates and the likes. But we can also do some level of calculation. We can calculate odds ratio of exposure. Like for the case control that we are talking about, we know that we have two groups, the case and the control. The case and control. So for the case, they have developed disease already. They have disease already. And they exposed to certain factors that may predispose them to that particular disease. And we also have no exposed, that's no exposure. They do not expose to the disease, but they come down with disease. But in this table, under no disease, we still have those we have some people that they also exposed to disease, but at the end of the day, they don't come down with disease. And in that's letter B, we use letter B to represent that one. For the no exposure, no disease, we have D. So mean that if you now want to calculate the odds ratio of exposure among cases, among people that have developed disease already, over odds ratio of exposure among control, that's probability of exposure among cases, and the probability of exposure among control. So it's not totally the same. The odds ratio is not totally the same with probability, but they share some level of similarities. Example for as far as the case control is concerned, alcohol consumption and liver cancer. We want to see whether consumption of alcohol will lead to development of a liver cancer. So we have 200 participants or study participants. 160 they are taking alcohol and they have developed the liver cancer. That's cases. Then This 90 are not taking alcohol. For the control, I mean, for we have alcohol, we have session for alcohol, we have session for no alcohol, we have another session for cases and control. For the cases, for that of alcohol, we have 160, and that's for those that have developed liver cancer. And the control of them, that's group, that's second group. If you have group, the first group, that's case group, that was for case. Then for the second group, that's for control. For those people that are taking alcohol, that have come down with disease, they have 60. They have disease already. The control for them, 90. Therefore, those that are not taking alcohol, but they still have that liver cancer, they have 40. Then for their control, for the control is 110. So now, if you look at the total of cases now, we have 160 plus 4, that's 200. For the control, so we have 90 plus 110, that's 200. Meaning that we have 200 for control. We also have total of 200 participants for cases. So they have equal numbers of participants per group. The odds ratio now is 160 times 110. 160 times 110. That's the alcohol, the people that are taking alcohol that have developed this, which is 160, times those that has the control of those that do not take alcohol, which is 110. Then we now divide the answer by 90 times 40. And if you will try to punch our calculator, we see that we are going to have 4.89 as our final answer for this one. So the odds ratio of liver cancer are 4.89 times greater among those with alcohol consumption. Also, the odds of liver cancer are 4.89 times greater among those with alcohol consumption. Meaning that the probability that people that are taking alcohol would develop the odds ratio that the people that are taking alcohol would develop liver cancer is 4.89. Very high, very, very high. That's what I'm trying to use a odds ratio calculation for here. Then, just like we know, everything that has advantages also have disadvantages. So it has its side of strength and also weaknesses. It's good for rare disease. Case control is good for rare disease. Efficient in resources and time. It doesn't take more time. You get your participant. The participant they have developed disease already. It's not like you are waiting for them to develop disease. It's cheaper to conduct. It is very cheaper. It's very cheap to conduct. The weakness is susceptible patients, because there is tendency that when you are asking them about their price exposure, they may miss certain information. So it is susceptible to selection bias, susceptible to misclassification bias, that is selective recall. It's only something that's very important to them in the past about what I try to ask for is what they will remember. But those things that they don't put more emphasis on, that doesn't even, so that's why it's susceptible to misclassification bias. They can only remember what touched them that time. Those things that are somehow mild to them, they may forget it. It may be difficult to establish that cause preceded effect. So it will be very difficult to know the cause, then the effect, the preceded effect, the effect that has come before the development of a disease, because disease has been developed already. Then the next one is repeated cross-sectional. Repeated cross-sectional study done at different times, prospectively in a defined population. This one we have, just like we have cross-sectional study. So we go to, maybe we are trying to carry out a survey on awareness of using mosquito net and controlling malaria. So we go to a particular, maybe you come to youth there, to your faculty there, to look at the prevalence. So we made certain number, we made set of people. I made the researcher made set of people. They try to give them questionnaire asking about that particular research of interest, asking about a particular question that interests him to study on. Then maybe now come back after some time again to meet the same set of people, that is meeting now, to now ask the same question. Then later on try to compare. So that one is repeated cross-sectional. It's not, this one is analytical because there is level of comparison now. We are trying to compare two groups now. But if it is just one cross-sectional, that one is purely prevalence study. So it's instantaneous study. So that one, there's nothing that we can compare on. Then the last one now is correlational studies. It's a type of research design where a researcher seeks to understand what kind of relationships naturally occurring variables have with one another. Try to see whether there are some level of relationship between different variables, which is natural. A correlational research design investigates relationship between two variables or more without the researcher controlling or manipulating. Anytime we are manipulating or we are controlling or we are making intervention, we are not doing observational again, we are doing experimental. So correlational research seeks to figure out if two or more variables are related. If so, in what way? So that's essence of a correlational study, to see whether there is some level of correlation, whether there is some level of association. It's trying to see whether the group, one variable correlates with another variable, and in what sense, how. Then we need to note that correlational study is not the same as comparative study. While correlational study is a type of research design where a researcher seeks to understand what kind of relationship naturally occurring variables have with one another. This one is just trying to see if the correlational study is not the same as comparative study, because correlational study is a type of research design where a researcher seeks to understand what kind of relationships naturally occurring variables have with one another. So with one another, meaning that this one is trying to see whether there's a relationship between those variables. The comparative study essentially compares two groups in an attempt to draw a conclusion about them. Researchers attempt to identify and analyze similarities and differences between groups. Comparative studies connote a sort of experimentation. Let's recall. We talk about study design. I've started in the previous sessions. We said that the study design we have is majorly divided into two. We have experimental, we have observational. So under observational, we have descriptive, we have analytical. So in our last session, we discussed about the descriptive aspect of observational study, and today we have looked into the analytical aspect of it. So in short, we have come to the end of observational study design, in which in our next class, probably the next presenter may look into experimental aspect of it. Thanks for listening. Hello.
Thank you so much, sir.